welcome to everybody today. Burgess Salmon and UK HFCA are delighted that you're all here and keen to listen to our great team of panellists that we've got lined up to talk about delivering net zero and clean growth through hydrogen and fuel cells, and in particular in connection with opportunities in heavy transport. This is something that Burgess Salmon is particularly keen on. We are an independent UK-based law firm, and we work very closely with a large number of clients, both in the energy renewables sectors and also in the transport sector, which indeed is my specialism. I head up our transport team, so I'm really interested to hear about some of the latest developments and thinking on this challenging area as the UK continues on its journey to achieving its net zero ambitions, and we see increased momentum towards this goal. I'm going to hand over now to Chris Jackson from UK HFCA, and then after that we will go straight into our panellist speakers, and after that we'll have a panel session. As Richard already indicated, if you want to submit questions throughout the whole of the presentation, that will be great. We will have a specific Q&A session at the end, but no doubt if there are themes or interesting topics that come up, I will try to pose those to the panellists as well to make sure that we get as many questions and as many insights as we can today. Chris, handing over to you now.
Fantastic. Thank you very much, Bryony. And as always, a big thank you to the team at Burgess Salmon for this opportunity to work alongside you and to talk to so many of our guests here today. Good morning, everyone, or good evening, depending on where you are in the world today. My name is Chris Jackson. I am chair of the UK's Hydrogen and Fuel Cell Trade Association and CEO of Protium, a UK-focused green hydrogen developer. I'm excited to be able to talk to you a little bit today about what we as a trade association do, and to set the scene a little bit before Adam Collins does a much better and deep dive on the opportunities around hydrogen and fuel cells within heavy mobility and decarbonisation, and before we get onto our panel and some of the excellent work they're doing. So if we can go to the next slide, and I think probably one more from here, please. So just a little bit of an overview on who we are. Apologies to those who are already familiar with our organisation. So the UK HFCA is UK's pan-hydrogen fuel cell and trade association. We represent a variety of different organisations from all aspects of the hydrogen and fuel cell supply chain. Our aim is to emphasise the role that hydrogen and fuel cell technologies play to complement other low and zero carbon technologies as the UK moves towards net zero, and to provide opportunities as well for businesses in the UK to not only thrive in our market, but also to work with international partners and thrive and export into other locations across the world. We're a very broad organisation in the scope of work that we cover. I've alluded to some of the areas in the slide here below, so various different forms of production and storage, ranging from reforming of natural gas, reforming of biogas, pyrolysis and carbon capture, as well as electrolysis and various different types of electrolysis technologies. We look at hydrogen combustion systems, and you'll hear from one of our members about some of those opportunities later today. And we also cover elements such as hydrogen storage and professional services around the hydrogen and fuel cell sector, including consulting, legal, and various other parts of the supply chain, including even raw material supply as well. Next slide, please. So as I mentioned, very varied organisation, a range of SMEs. We're around 50 members at the moment and growing rapidly. We include some of the largest companies in the UK and obviously internationally, such as Sarah's Johnson Matthey, BP, ITM, etc. And as well as some of the more innovative companies as well. So you're going to be hearing about some exciting projects that our members are working on later, including the projects that the University of Birmingham have been working on, and including probably, I guess, some of the projects that our colleagues from Luxfer have also been working on as well. Next slide, please. So really what I wanted to do a little bit in the time we have here before we hand it over to Adam is to give a little bit of a context around what the opportunity is for hydrogen, and a little bit of perhaps setting the scene for those that are less familiar with the broader hydrogen and fuel cell sector, and then also making it a little bit more applied to the UK. So there are obviously a wide variety of excellent reports on hydrogen and fuel cells, the market size and potential, and if you haven't read any of the Liberum reports by Adam Collins and his team, they're worth reading, they're excellent. But just drawing from one of the many reports, estimates are that hydrogen will be a potential global market of about $2.5 trillion by 2050, There is a wide body of evidence to suggest that the UK can and will be a market leader in that area. Even without a hydrogen strategy announced, the UK was recently considered to be the third most attractive market in Europe for hydrogen opportunities, behind Germany and the Netherlands. We are optimistic that in 2021 that there will be a more bullish UK government hydrogen strategy and a series of policies and support mechanisms to make the UK live up to its enormous potential as a hub for various different forms of hydrogen production, hydrogen use, and fuel cell uses and applications as well. Depending on the body of research, the role of hydrogen in that end energy system is varied, potentially providing between 20 to 50% of all UK final energy consumption. A key criteria that I think many people forget in the discussions around net zero is the fact that power is a relatively small part of our modern energy system. So when we talk about net zero, only around 20% of energy consumed globally is in the power sector. The other 80% remains in heat and in transport, and obviously transportation is the largest source of emissions within the UK today. And so understanding how we decarbonize those sectors is critically important, and understanding what that means for the energy system is critically important as well. And one of the challenges is to understand that this is a process. We cannot simply flick a switch and overnight transition from one different form of energy to another form. It's a multi-year, multi-decade process that requires infrastructure investments and requires long-term planning, and companies and policymakers to work together to make that transition happen. And there are already commitments from industry representatives across the UK to invest up to $1.5 billion into projects and into bringing on additional resources to start putting some of that infrastructure together when the UK hydrogen strategy is hopefully announced later next year. And there's a robust series of reports around what that would mean in terms of jobs and economic opportunities across the UK. One particular number we've taken is from the CHJU, which was assessing potentially 46,000 domestic jobs could be created in the UK as a result of pushing towards hydrogen for 2030. But it's not just the UK. There are much broader opportunities, and beyond the 500,000 heavy good vehicles in the UK that will need to reach net zero, and the 3 million commercial vehicles, and the nearly 30 million passenger vehicles that need to be decarbonised, not to mention the rail sector, which we will talk about later, aviation, of course, where the UK wants to be a leader through the Jet Zero initiative launched by the Prime Minister, and maritime, where areas such as Scotland and the Orkneys are already starting to pioneer different types of hydrogen applications in the maritime sector, as well as places like Bristol and Cardiff that are looking at fuel cells and hydrogen. There is that broader international discussion that needs to be had as well. So globally, we are looking at 1.4 billion passenger vehicles that will need to, over time, transition towards net zero. And within the European Union, we're looking at millions of heavy goods vehicles that will also need to find a pathway to decarbonize. That challenge is more manageable than many realize. Technical studies in Germany estimated that 100 hydrogen refueling stations for heavy good vehicles would be sufficient to meet most fuel cell vehicle demand within the next 10 to 15 years in Germany, and to be able to massively scale up the ability to transition to net zero. Obviously, the UK is a smaller country, both in terms of population and in terms of geography, than markets like Germany. And we have obviously had the discussions around markets like France and Spain that have announced their own very aggressive hydrogen strategies that complement that. And if many of you have not had the opportunity to do so, I strongly recommend engaging and looking at some of the reports by organizations like Hydrogen Europe and the European Commission on what an emerging hydrogen ecosystem and hub may look like across Europe. And even if you want to look at other markets, I recommend looking at work by people like the African Hydrogen Partnership. We've talked about hydrogen corridors for transportation in Africa and various regional hubs that could play in and feed into each other. So all of these elements and aspects are there. And I think the one thing I want to emphasize, I guess, before we move a little bit further on and I hand over to Adam, is to talk about the fact that sometimes in the discussions around hydrogen and around fuel cells and their various applications, there is a sentiment that this is always 10 years away. And it may not be as bad as the old nuclear joke that it's always 25 years away or 25 years away, but there is still the sense that this is a future technology and it's unproven. And I think we need to address that fairly head on. There are currently fuel cell trains now running in Germany, have run for a relatively long time. I believe there are 50 Alstom fuel cell trains that are currently committed on order. There are trains that have just done their first trials in the Netherlands, France, Japan, UK, Canada, North Carolina, various other markets have all actively started working on or even making initial pilot procurement of hydrogen trains. Hydrogen aviation is obviously extremely active. We not only had the first hydrogen commercial plane fly in the UK at Cranfield, led by Zero Avia in the last 2 months, but we've also seen announcements by groups like Airbus around how they see the role of hydrogen in aviation. There are companies like Element One in Singapore looking at how they can play a bigger role in the hydrogen aviation sector, not to mention a number of vertical takeoff and landing companies and drone applications as well that are increasingly looking at hydrogen and the role that that can play in a variety of quite interesting applications. For example, monitoring and maintenance of large-scale infrastructure, things like dams, large-scale roads, and assets that might otherwise be challenging for battery electric to meet. So we need to understand all of that and understand that there are vehicles already on the road as well. So we have over 16,000 fuel cell electric passenger vehicles that are already deployed. We have hydrogen dual fuel vehicles operating in the UK. We have several thousand hydrogen commercial vehicles in operation in markets like China and in Europe. We've had the first Hyundai 20-ton trucks turn up in Switzerland, the first 1,000 that have been delivered. So not every single truck just rolls down a hill. I forget the bad joke for those that are aware. And also we have, we talked about maritime, but there are increasing number of opportunities and exciting areas to consider in the maritime space. I'm sure my far more learned co-members on this discussion will be able to go into that in more detail. And the final thought before I hand over to Adam and Nids for more slides is to just say that we shouldn't look at hydrogen and fuel cells as a competitor to many of the other excellent technologies that are out there that are helping to move us to net zero. Too often I think we make the mistake of framing this paradigm as a one technology versus another, and that is not how we in the industry see it, and that is not how I think that it's a healthy way to have a dialogue around this. We will need multiple different technologies in different periods and times to support that transition to net zero, and UKHSCA members are working with a variety of different technologies and different companies to make that happen. And so when we go through this discussion, I think it's worth always bearing in mind when we listen to our panelists that it is a complementarity discussion we're having. It's not an either or, it's how do we complement those existing technologies. So if we can go to the next slide. Just a few very softish pictures about what UKHSCA are doing for some of those here. So one of the things that we do a lot is try and increase exposure of our members, and obviously the discussion here is a great example of the sort of things that we do. But we are also going to put out a capabilities guide, which will give an overview of the different members within our trade association by the end of this month, and some details of who you can contact and the services that they provide. We are also very active in working on pushing policy to make the role of hydrogen and fuel cells in the net zero transition clearer to policymakers, and we expect to have a number of position papers released by the end of the year. And we're active in coordinating with various different trade groups across the UK that are pushing for an enhanced role for hydrogen and fuel cells in that net zero discussion. So I think with that, if you go to the next slide, please. We're done. So it's my pleasure to introduce Adam Collins from Liberum to take over the discussion here and to provide a far more detailed and eloquent background to the broad discussion for today. Adam, over to you.
Good morning, everybody. Thank you, Chris, for your intro. I'm not sure it's going to be any more elegant, but I'm going to be covering some areas that Chris hasn't touched on. Richard, if you could move to the next page, please. Thanks. So just a quick word about my company and myself. I'm an equity research analyst for a boutique investment bank in London called Liberum. For most of my career, I've been researching European companies in the auto and engineering sectors. In the last few years, I've spent a lot of time looking at companies in the battery and hydrogen space. Liberum helps private companies list on the London stock market, as well as doing fundraisers for those already listed. Richard, if you could turn over to the next page, please. So I'm going to continue on a sort of positive note for now. You may have heard that the UK is going to have a hydrogen support plan announced in early 21. And although it remains to be seen how that matches up versus Germany and France, there's a strong case to say it could be good for UK jobs as well as the energy transition. The UK can claim a few hydrogen firsts, and they're listed here in the transport sector. Firstly, this summer, Avia conducted the first manned hydrogen flight from Cranfield, a 19-mile flight in a 6-seater retrofitted Piper M. In the new year, it plans a 350-mile flight from the Orkney Islands. And Scotland also can claim some other firsts in buses, with First Group recently having taken delivery of the world's first hydrogen double-decker. We've also, of course, got several world-class companies in the fuel cell and hydrogen space, with ITM, Ceres Power and Johnson Matthey being 3 listed examples. I'm sure there's several hidden jewels amongst the membership here today. And in addition, of course, UK is advantaged in several ways in this space. We're the Saudi of offshore wind, and we've got one of the biggest gas grids, over 4 times bigger than the electricity grid. So if you can turn over, Richard, please. Thanks. Okay, so why is hydrogen so exciting for heavy transport? One key reason, of course, is transport's contribution to global carbon emissions. Transport accounts for around about 1/3 of energy-related carbon emissions, and around half of that comes from road transport. Those emissions need to come down if net zero is going to be possible, but there's likely to be upward pressure on usage rates over the next 30 years as the global population doubles and emerging markets get wealthier and industrialise. As the charts show, freight and civil aero mileage is expected to increase threefold over this time frame, according to the IEA. You can turn over again, Richard, please. So, cleaner air as well as climate mitigation is also a key driver. One of the areas I think that often gets overlooked in this debate. This slide shows NOx and particulate emission heat maps for the UK, shows a concentration in cities, particularly in the densely populated southeast. The dark red line in the London map heading west, of course, is the M40-M4 corridor. Around 35% of particulate emissions in city centres and 20% in suburbs come from road transport, and microparticle emissions are estimated to cause around 15,000 deaths in the UK each year. Hydrogen fuel cell powertrains generate negligible SOx and particulates, whilst hydrogen combustion generates low emissions with the right fuel-air calibration. If you can turn over again, please, Richard. So we've got a couple of slides here which illustrate the case for hydrogen in heavy transport. This slide, labelled tortoise and hare, indicates that scaling up hydrogen vehicles may end up being cheaper and less complicated than battery mobility. Near-term batteries have an infrastructure and cost advantage, of course. For cars, there's a charging network already established direct to most homes, though street parking or apartment living is an obstacle. In early scale-up, the cost of installing external chargers for buses and trucks appears modest at about €100,000, compared to about 5 million for a 50-bus hydrogen station. And as a result, unit infrastructure costs for 5 bus projects are 5 times greater for hydrogen than battery. However, at a 50-bus deployment, the bus depot requires grid reinforcements, so unit infrastructure cost hardly falls, while cost per hydrogen bus falls in a linear way. And the same arguments can apply also for car fueling. According to McKinsey, infrastructure costs for battery cars today are around about €4,000 per vehicle, compared to around about 16,000 for hydrogen. But in a world where 20% of cars are electrified, this becomes around €8,000 per battery vehicle, but less than 6,000 for hydrogen cars. And hydrogen fuel cells may also be the best infrastructure option, as I think we'll hear later, in many cases for low carbon, low pollution trains. Overhead electrification provides an alternative to hydrogen, but costs $5 million per kilometre to install, according to McKinsey. So it's mostly suited to high frequency routes. You want to turn over again, please, Richard? So this is another sort of page illustrating the case for fuel cells in heavy transport. It illustrates the energy capacity advantage of hydrogen fuel cells over batteries for heavy buses or trucks. But the same arguments also apply for trains and planes. Both battery and hydrogen fuel cell vehicles have poor volumetric energy density versus diesel engines, but hydrogen is superior by a factor of 2 to 3, which makes a difference for heavy-duty applications. Heavy trucks can weigh 20 times that of cars, and that translates through to a much poorer battery range economy in trucks. Today's battery electric cars have a range of about 4 miles per kilowatt hour, whilst the heavy-duty battery truck does less than a mile per kilowatt hour, about 0.75 miles, we think. The combination of poor battery economy and long range means a battery-heavy truck needs a 700 kilowatt-hour battery. That's 15 times bigger than today's EV batteries in cars. And the battery cost at today's price It's around about $150,000, which is the equivalent of a whole diesel truck. Charging time is about 2 hours, or 10 times that for a hydrogen truck. So if we could move on to the next page, please. So the final slide ends on another sort of cheery note. Over the last couple of years, we've seen several leading powertrain companies invest or announce collaborations with fuel cell companies. Cummins, Bosch, Weichai, Mahler are listed here and have aligned with PEM fuel cell companies. And as importantly, several big OEMs have now come out in favour of hydrogen for the energy transition, notably Daimler and Volvo in trucks, Alstom and Siemens in trains, and Airbus, as Chris was saying, in civil aerospace. No longer are many suggesting fuel cells are full cells or that hydrogen is the fuel of the future and always will be, as jokes used to go. So that's all from me. Look forward to speaking to you perhaps in the Q&A. Thanks for your attention, and handing over now to Stuart on Hydroflex.
Thank you very much, Adam, and good morning or good afternoon, everybody at the end of the line. Adam set me up quite well because talking about heavy-duty applications. So I'm going to talk through, if I go in the right direction, the story of the Hydroflex, which is the UK's first hydrogen train, and it's been approved to run on GB's mainline network. You can see in the picture here running over the River Evesham, and that's somewhere in the round of 150 tonnes worth of train, so definitely heavy duty application, but actually fairly light duty in the world of railways. One thing that's important about that picture is you don't see any overhead electrification, because that particular route is quite lightly used, and it would not be economic to probably ever electrify. So we have to find a solution to provide autonomous traction power to rail vehicles like this that run over less dense parts of the network. Electrification is definitely the answer for high frequency, high power applications, and will take advantage of the increase in or decrease in amount of carbon in our grid. But we think hydrogen is a very good solution for the less dense parts of the network, which are actually vital to the whole system. The drivers for this, and we've already heard some of these mentioned, air quality is a big factor actually, particularly in our stations, and diesel engines sitting idling at stations produce quite a lot of nasty emissions. You just need to go to a rail station to verify that for yourself. Obviously things like climate change, decarbonisation, generation mix and so on are important. And here we see on this graph in the top is diesel producing lots of emissions per kilowatt hour of propulsion power, and that's something that we need to get rid of. And the rail industry is committed to getting rid of diesel vehicles by 2040. And in the rail industry, 2040 is really tomorrow, because rail vehicles have got a life of well beyond 20 years. And what that means is you can't possibly buy a diesel vehicle today because it will become obsolete during the time where you're still expecting to make money out of it. So the rail industry is accelerating efforts to look at decarbonisation options, and we see hydrogen as a route to providing that, particularly from electrolyzed hydrogen from renewables. At the university, we've been looking at this for a number of years. The picture on the left is actually the first rail application that was run in the UK. That was in 2012. It's a student project to build a locomotive for the IMEC's Railway Challenge, and we demonstrated that and got a lot of interest from that point on. One thing to note is that vehicle, we actually covered it in clear perspex, because part of our role at the university is to disseminate this kind of technology. So we're very open and honest about the type of technology that we're using, so we could show people the fuel cell, the hydrogen tanks, the batteries and so on, so they get first-hand experience of what the vehicle really looks like. Then in 2018 we collaborated with a company called Porterbrook. They own about a third of the UK's rolling stock, and we signed a partnership with them to develop a train that would be powered from a fuel cell and battery system. And we gave ourselves 9 months to do this, which was quite a stressful 9 months, but we pulled it together and were able to convert a train to hydrogen. I should say the train was an existing electric train that could take power either from 25,000 volts or 750 volts DC. So it already had its own electric drive system, which meant integrating a fuel cell into it was difficult, but doable. We didn't have to rip out, a gearbox or a combustion engine or so on. And we did that in 9 months and demonstrated at a trade show called Rail Live. What we did, the vehicle has 4 coaches or vehicles, and one of them contains all the propulsion equipment. And what we did was you stripped out all the seats from that and installed our fuel cell, which was from Ballard, our gas tanks, hydrogen gas tanks from Luxfer, and a battery pack from a company called Dentry up in Scotland, inside this vehicle, and then routed the propulsion power through to the equipment downstairs, which was relatively unchanged. The reason for doing this was, one, it was quick to do, but most importantly, it allowed us to showcase the technology to people, and we've had a huge amount of interest and lots of important people coming to look at the technology, and they can see it firsthand, and they can reach out and touch the fuel cell, touch the tanks, and see how it all fits together. We think that's a big important part of the project. So that's a really short introduction to the train. Since we've run it in September, we took the Secretary of State of Transport, Grant Shapps, for a spin on the train, and since then there's been a huge amount of interest in developing this technology for rail applications, and I think going forward in the next 2 or 3 years we'll surely see fleet deployment and passengers taking routine rides on our vehicles like this. So thank you very much, and at that point I'd like to hand over to Amanda. Thank you.
Hi, thanks. So do you want to move to my first slide? Thank you. So my plan here, so I'll introduce myself and I'll hopefully give people an idea of what might be an opportunity for us to deliver hydrogen technology here and now, dependent on the availability of decarbonised hydrogen. The heading of my talk says it for itself. The reality is our technology, which is based on converting existing diesel vehicle engines to run on a combination of hydrogen mixed in with diesel, is a way of using all the infrastructure for vehicle technology that's on the road already today. It doesn't require us to come up with new vehicles or new approaches. By doing that, the opportunity spreads from everything from large vans up through to any form of HGV. In fact, we could even do marine and rail as described. The technology is based on the principle that we install commercially available existing hydrogen storage tanks, and Jim will talk later. He supplies us with our tanks. And our IP is associated with an ability to actually make sure that we can mix diesel in the engine directly without causing a change in performance of the vehicle, ensuring that the hydrogen is burned efficiently and that we also deliver on air quality benefits. Next slide. As many of you will know in the audience, we started the technology demonstrating on large vans, the transit van, and in those vehicles we demonstrated on the Euro 5 version we could get to 70% of the energy coming from hydrogen without any change in the performance of the base vehicle. Most of the HGV vehicles deployed across Europe today are actually Euro 6, where they have incorporated excellent emission control technology that actually delivers an ultra-low emission system. So going forward, our technology, if it's deployed on Euro 6, is an ultra-low emission vehicle because the diesel itself will also be managed through the systems, and I'll show you that later. Breadth of vehicles that we've worked on most immediately is focused on urban back-to-base vehicles, because that's the way that we can get access to the hydrogen refueling. We recently participated in the OLEV-supported low-emission freight trial, and I will present some data from that later. Next slide. Quite typically, in summary, what we're showing is that using hydrogen dual fuel technology delivers air quality improvement as well as delivering greenhouse gas emissions, and is a good way of replacing diesel in the here and now. The slide in front of you is evidence of the NOx emissions related to specific real-world duty cycles of vehicles that were tested within the low-emission freight trial and other external tests. If you take the vehicle on the left-hand side, a reference truck, the fact is that we can take an ultra-low emission diesel truck, the basic diesel, reduce NOx below 73% improvement in NOx, which actually stands out as the best-in-class way of reducing NOx emissions on that duty cycle. At the other end of the scale, if we do vans, similar results are confirmed. All of the vehicles demonstrated or evidence on this NOx curve delivered at least a 30% reduction in CO2 based on the amount of hydrogen that they were using to make it. Next slide. So in summary, therefore, related to that, if we could take a fleet of urban trucks based around back-to-base hydrogen refueler, then those trucks, 100 trucks would use sufficient hydrogen to deliver hydrogen at scale, which is therefore cost-effectively based around a back-to-base fleet. The Westminster reference truck fleet have 80 vehicles, so if all of those were converted, we could deliver these levels of CO2 saving, diesel and NOx reduction. Next slide. The critical point that we need to illustrate, however, from the results of the low-emission freight trial is that the majority of the reasons why our vehicles did not operate in hydrogen was in relation to the lack of hydrogen infrastructure, the reliability of that or the accessibility of that. Vehicles demonstrated here are running day in, day out in real-world use, and they require to have a reliable hydrogen supply in order for them to do the duty. One of the specific benefits of our technology, however, is that if there is no hydrogen available, the vehicle will continue to work in diesel. Therefore, the operator has a low-risk way of taking on hydrogen. Next slide. So in summary, for us, what we're trying to help people understand is using our hydrogen dual fuel technology, we can open up the opportunity for the availability of hydrogen infrastructure in a regular, reliable process that gives confidence for investors in hydrogen infrastructure to believe that there will be a demand in mobility. This is not limited by any long-term development technology. This is here and now. And the fundamental question that I have as a restriction when I speak to potential customers is where will they get the hydrogen from? So the sooner that we can invest in hydrogen infrastructure, green hydrogen infrastructure, scale hydrogen infrastructure, blue hydrogen infrastructure, the sooner we can be saving greenhouse gases and therefore the environmental benefit. Very much. I will now hand over to Keith. No, Jim.
Morning everyone. I'm Jim Gregory from Luxford Gas Cylinders. We'll take up a few minutes of your time, myself and my colleague Keith, to talk a little bit about who we are and also the heavy duty applications we've been working on over the past few years and what we see coming up certainly in the next 3 to 4 years. Can I have my first slide, please? To give you some background, Luxford Gas Cylinders, we've actually been making cylinders since the Second World War, and we make over 2 million different types of cylinders a year. You will commonly see them in oxygen, in hospitals and for mobile breathing apparatus. So we've had Obviously a busy year this year. Elsewhere, we worked with Jacques Cousteau on his scuba programs back in the 1970s, and more recently putting composite cylinders on the back of firefighters across the world. I guess from the early 2000s onwards, we started to develop what you might call the Type 3 and Type 4 cylinders. These are the composite cylinders with a metal or a plastic inner lining and a carbon fiber reinforcement on the outside, which gives the higher and higher pressures and bigger cylinders that are needed for alternative fuels. Since about the year 2000, we've built probably 18,000 different gas-powered vehicles around the world. It has to be said that it was dominated for the first 17 years by compressed natural gas, which is quite a mature market. But the good news is over the past 3 years, there's been a real shift towards hydrogen. Whilst we did build hydrogen prototypes for most of the truck OEMs, the bus OEMs way back in the 2000s, obviously none of them have ever come to serial production in Europe. It really was the prototypes we did in Japan and Korea that produced the Hyundai and the Toyota vehicles you'll see on the roads today. Next slide, please. Thank you. But the current landscape is very, very different. We're now involved in the serial production of both trucks, buses and vans in Europe. You'll have seen the 60 or so Hyundai trucks delivered out of South Korea into Switzerland for the Swiss supermarket chains. And as well as that, we've obviously been shipping alongside Wrightbus a lot of double-decker buses into Aberdeen, Glasgow, Birmingham in the near future. And we were actually involved in the original Aberdeen hydrogen fleet, which is now almost coming to the end of its life, supplied by Van Hool in the Netherlands. And we're also working on the supply of, I think, the only serial production in Europe of vans, which is with Renault. I would say the biggest take-up over the last couple of years has been buses and trucks. I think the primary drivers have been that ability to get as much hydrogen on board as you can. The average truck is requiring 35 kilograms to 50 kilograms of hydrogen on board at 350 bar just to get the sort of range that we need. I think the hardest thing we do as a company is try and fit a cylindrical gas cylinder onto a vehicle that was designed around a liquid fuel. So as you'll see on the trash trucks, it's quite hard to get all of those cylinders up the back and still get the range out that you need. Next slide, please, and I'll pass over to Keith.
Yeah, we at Luxfer believe that the off-road market, the off-highway market, may well eclipse the on-road market in the next 2 years in terms of variety and possibly even scale. We believe that we've built firsts in rail, in material handling, and amazingly in this agricultural, in the tractor, and also in marine. And we're working on fuel storage systems projects delivering hundreds of kilograms of hydrogen per hour, which is scales that people were just dreaming of a few years ago. One common factor across this sector is that they will probably never use public fueling stations, and that's an issue. Why is this sector important? In terms of the environment, interesting little fact is, as probably many of you know, that the biggest polluter in Chile isn't transport, it isn't heating homes, it's their fleet of mining trucks. And big impact. Next, no, actually we'll just tell you a little bit more in that fact that the biggest challenge really it will be to find the best way to get the hydrogen to the user, and it will also be interesting to see how the standard range of storage systems develop for road vehicles will translate into the even wider variety of body shapes and unique environmental requirements. Next slide, please. So the future, there's some great pictures there, and the top one is a drone, a UAV. Thanks very much to Intelligent Energy, a fantastic thing. The difference between that and a battery powered unit, as far as I'm aware, is something like an hour, and that is, these things fly for longer than an hour with Luxfer cylinders. The future key considerations really are unmanned transport, and we see the UAV there, off-grid power generation, and distribution of fuel to non-roadside applications is a big opportunity for us. Some of the issues that we're coming up daily are the disparate standards, and I know that that's shared throughout many on the panel, and many listening in. And scaling up of production to meet demand is also a major issue to many customers of ours. And I think it's fair to say that what we will see is a largely increased variety in sizes. We make some very small cylinders for hydrogen, and we make some very big ones, and we're going to make a lot bigger sizes and higher pressures. So I think in essence, Luxfer is probably UK's best kept hydrogen secret here in Nottingham, and we are the world's largest manufacturer of hydrogen fuel storage systems. We've been doing it for 80 years. We've got a strong UK heart and a soul, and working internationally. So thank you very much for listening to us, and look forward to seeing you on the panel.
Thank you, Keith. So my name is John Kane. I'm the Design Department Leader for AVL here in the UK. And what I'd like to do today is just take you through a little bit of the fuel cell journey. So quickly to introduce AVL first, we were founded in 1948, and we've grown to 93 different locations in 26 different countries in the world. And we're working with virtually every major OEM. We're still family owned. 65% of our people are engineers and scientists, and we invest about 10% of our turnover in in-house R&D. And that's really to make sure that we stay at the forefront of the technology trends. Looking at our fuel cell experience, we've got 3 divisions. So the advanced simulation tools, powertrain engineering, and the test services. And these give us the best development and automation systems in the industry. Each of those areas have over 20 years experience in fuel cell development. We look at each of the steps to productionise fuel cell vehicles, from extensive benchmarking activities to analysis of in-field data. We've also got a group within PTE that studies market trends and requirements worldwide. So let me just share a small overview of that. So what is the motivation for fuel cells? First, we have the CO2 targets. Here we're looking at the passenger cars, but we're pushing from 186 grams per kilometre targets in 1995 down to 95 grams per kilometre targets in 2021. We're seeing city bans of internal combustion engines, and in particular the diesel engine. We're also seeing increased capacity of renewable energy, with hydrogen being the ideal storage medium. And all of those coming together are driving us towards powertrain electrification. Talking specifically about city and national bans on internal combustion engines, in 2020 we have Costa Rica leading the way. In 2025 we're seeing mainly diesel city bans, but we're now seeing Norway banning the internal combustion engine. 2030, adding many more cities, and some of these are the mega cities like London and Los Angeles, as well as a number of other major cities. Also, we see a significant number of countries, including the Netherlands and India, and then closer to home, Scotland and Ireland. 2040, more big players like France, England and China. When we look at the market subsidies, it's easy with the UK hat on, specifically for passenger cars, to question if fuel cells will ever be taken seriously. But there are now significant drivers from government. In Europe, Germany is starting to subsidise, and in the US we see a more significant subsidy. But it's in the Asian markets that the big incentives are coming into play. with Japan offering nearly $2,000 and China $20,000 and China offering $25,000. So we will see a shift. The naysayers will point out that it's not sustainable, but what we may see is a system like that's used for CO2 in many European countries, where the undesirable vehicles get taxed heavily, and that tax is used to subsidise the fuel cell and the electrified products. Talking of government push, let's look at 3 of the big Asian markets. So in Japan, it published the roadmap in 2017, and by 2030 they're looking for 800,000 passenger cars, 900 filling stations and 1,200 buses. Korea, in its roadmap from 2019, 6.2 million vehicles, 1,200 filling stations and 41,000 buses. And finally, China, in its 5-year plan, wants by 2030 to have 1 million vehicles and 1,000 filling stations. So it's no surprise that when we look at the passenger cars, today's fuel cell offerings come from Japan in the shape of the Toyota Mirai, the Honda Clarity, and then from Korea in the shape of the Hyundai Nexo. We're also seeing a significant number of Chinese manufacturers that are on the cusp of producing fuel cell vehicles. So on the engineering side, let me give you a little intro into one of our latest collaborations. We've completed a number of truck projects and we're seeing a lot of further interest. To this end, the High Truck project was recently launched by developing a modular fuel cell system that will cover the entire range of trucks, from light duty through medium duty to heavy duty, or with a different number of modules. The modular approach promises some key advantages in terms of fail-safe, durable control and component availability. Other aspects of the project are to solve the conflict between the objectives for performance density and for durability. And with that, I'd like to thank you and I'll hand you back to Bryony.
Thank you very much, John, and thank you to all of the speakers and panellists this morning in advance of the questions that we're going to throw at them, and hopefully the discussion that we will get going. It's been really, really interesting to hear each of you speak about the huge number and variety of projects that are ongoing, and in fact many of which have been successfully delivered already. I think that one of the things that was mentioned at the introduction to this was people were keen to understand that actually this technology is here and ready to go, and that seemed to be a theme coming through from all of you, that actually we really do are on the cusp of moving from pilot and smaller scale projects to actually the mass delivery of these solutions to help meet the net zero challenge. And I think that what strikes me and what I would like to ask the panelists, and perhaps I'll start with Adam as he's had perhaps the longest rest since we last heard from him, is what do we think the sector actually needs, hopefully from the hydrogen support plan or from government or from financiers or elsewhere, to actually help deliver these projects on a more scalable value so that we can see the impact more quickly. If we're going to achieve net zero in the timescales that are looked at, there is a bit of a call to action really, and quite swiftly, isn't there?
So yes, thanks, Bryony. So a few things. Of course, money helps to some degree with the transport projects. We're going to see the need for green hydrogen production. And that means, of course, a scale up of electrolysis. And it would be very helpful in that regard, of course, if there are subsidies allocated towards electrolysis, as we've seen, of course, front and centre in the French and German plan. So I'm hopeful that we'll see something which will be a high single-digit billion funding programme from the UK, along the lines of what we've seen in France and the UK. Over and above that, I think in terms of the truck market, the CO2 limits which were introduced 2 or 3 years ago from the EU, which take effect from 25 and 30, the -15, -30% reductions in CO2 required for trucks are going to be important. But they're not replicated across the world to the extent that the membership here is globally facing. It would be helpful, I think, to see US heavy trucking standards which involve CO2 limits too. Likewise, in Asia, there's a catch-up process, I think, both in the case of China and Korea, when it comes to CO2 limits compared to the European standards. There's quite strict clean air standards emerging for heavy trucks in Asia, so-called China 6 and Bharat 6, India 6, but not the same CO2 limits currently there that we've seen introduced in the last few years in Europe. And I think those European limits were quite an important trigger to the plans that have been introduced lately by Daimler and Volvo. They seem to have played a large part in focusing attention in the truck sector towards getting hydrogen trucks into the market by 2030.
That's really interesting to hear that it sounds as though in addition to clearly the subsidies and funding that everyone would like to see, actually increased standardisation to allow the sort of economies of scale and efficiencies on a global basis would help support, particularly in the trucking arena. Amanda, you talked to us about the HGV vehicles that your company is involved with in particular, and the conversion of existing diesel infra. I think that you suggested that one of the challenges as well for the users of these vehicles is perhaps some of the lack of infrastructure. Is it the funding on the infrastructure that is needed to help support as well, or what other areas would help get more of these HGVs and out to the market?
Yeah, I'm trying to sit a bit nearer because I know my sound wasn't brilliant when I spoke earlier. The reality for all of us, any low carbon or zero emission technology is more expensive than diesel. Diesel is too cheap and all of the technologies are too expensive. So while we're in early stages of developing alternatives in the energy transformation, all aspects need to be helped and supported. However, specifically, our customers are looking for decarbonised green or blue hydrogen. And in order to do those, they need to be done at scale to make it economic to diesel. So a hydrogen back-to-base station similar to the one done in Aberdeen for buses, where it's over 250 kilos a day, needs to be used on a regular basis, and at that point you can actually start to get comparative to diesel. In addition to that, the vehicle technologies, whether that's fuel cell or our own case, are adding a little bit of extra cost on board the vehicle as a capital cost in order to be able to deliver CO2 saving. So in our case, the extra support for the capital cost of the vehicle is not that high, but even then, for transport operators that are working on very low margin, any extra cost is a challenge for them. So to incentivise operators to make the transition, there needs to be a requirement for them to reduce carbon emissions, or a budget for them to recognise that they should invest in that. In fact, in some of our customers, actually, by offering a low carbon solution, they can provide and win business, so the payback can come from other alternatives. But to be mass and scale opportunity, there does need to be support for both development of the infrastructure in the early days and the small amount of extra cost required because of the lack of scale of technology.
Thank you, Matt. That was really interesting, and sitting closer assisted. Certainly, I could hear you a lot better than previously. So thank you very much. And I think that what you were saying actually resonated quite strongly with some of the points that Keith was making when he was speaking and telling us that actually in the immediacy, the off-highway market might be where some of the easiest and most deliverable opportunities are. I know that buses do go on highway, but fundamentally they are back to base. They're almost using their own contained infrastructure, and that's how those projects have got to succeed. We've also got trains, which we can talk about in a minute. But as you say, there are a lot of these industries. Are we at risk of creating lots of small pockets of infrastructure? And what can we do to help the industry to actually create a cohesive network to get the benefits of the scale, rather than sort of developing lots of little pockets of best practice with maybe bus depots with facilities in different states?
if I can answer that to an extent, I think those of us have been looking out to Europe and the rest of the world, and we're working there all the time. Most of the projects are actually in Europe that I'm working on personally. There's a strategy in Germany, and the strategy includes having a pipeline around the nation. It's already started in terms of the planning, and government are sponsoring it, and that's what needs to happen in the UK. Let's not try and be too clever, let's see what's around there already and build on that. And I think in terms of regulation, I mentioned it, didn't make a really good job of highlighting that. That is a big issue for us, and government can help enormously in that area. And I think in terms of education, we're doing great in the UK. We've got fantastic things are going. Not seeing enough engineers, particularly mechanical and gas engineers and chemical engineers going into university. Still we're losing all the best people, or lots of the best people, to other areas like medicine, etc. That needs to end, and we really need government to back engineering, and particularly manufacturing engineering in the UK.
So support at all levels needed, right through from the education system to actually the delivery in commerce seems to be part of it. It's interesting that you mentioned that elsewhere in Europe things are going better, and perhaps this is where I'll bring it back to railways, which is actually what I spend most of my day specialising in, is supporting clients in the railway sector. And Stuart, the Hydroflex project has been fantastic. I was delighted when I saw that you had the live testing on the network. It's a great step forward. It's also amazing that you achieved it in 9 months. I mean, in railway terms, that's about 3 weeks. So it's really quite extraordinary. What is needed in the UK to help push things forward? As we know, there are hydrogen trains operating in quite a lot of other parts of the world. We've got only about a third of our network in this country is electrified. There's a lot of track that might benefit from hydrogen trains.
Yes, and I think a lot of the points have already been made quite clearly. One of the challenges is diesel is far too cheap, and we're not taking into account all of the external costs of diesel. So if you compare a hydrogen train running against a diesel train, it will be far more expensive, but it will be cheaper than electrifying the line. So really we should be comparing the cost of a hydrogen vehicle with what a whole system electrification would be. And in that case, hydrogen will come out far cheaper. I think the government has got a lot of steer here in terms of running the franchising system, and they can sort of mandate that the next time a franchise is renewed, that the person who operates it runs it on a zero carbon basis. So that's in the gift of the Department for Transport, and I think we need to have kind of incentives like that. I'd also echo some of the other points. There's obviously a huge supply industry built up around diesel infrastructure in the rail sector. That's got a certain value, a capital value associated with it, and we need to think about who sort of pays the cost of that those infrastructure being made obsolete, and that's going to have an impact on the rail industry. And also there's the sort of workforce education. People know how to refuel diesel trains and refurbish diesel trains, and that needs to change over a period of time. To within the next 20 years, that all has to go and be replaced by hydrogen expertise. So that's a massive challenge, and I think it's something the Hydrogen Fuel Cell Association can help with, certainly. So yeah, there's lots to look forward to, and I think we've 5 years ago, people thought I was slightly crazy saying we could do this on a train, but we just got on and did it. And if you get the right team around you, you can just get on and do things. And I think it's also already been mentioned that the technology is mature now. On the hydrogen train, we had virtually zero problems with the gas tanks and the fuel cell. There were some sort of integration problems, but the fuel cell and gas tanks worked perfectly, and didn't give me any sleepless nights at all.
I'm pleased to hear that. It's fantastic to hear the project went so smoothly, and no sleepless nights. Goodness me, it's great that an innovative project like that went so smoothly. it does seem that the constant theme coming through on this is how we can actually achieve the delivery of this in a more economic way, so that the cost isn't all falling on the first users and first deliverers. I know, John, when you were talking, you brought up lots of interesting slides, and you were talking about the internal combustion engine bans that would be coming in different cities and things. They see some pretty fierce challenges that people have set themselves, really. And as I said, in transport, 5-10 years doesn't seem a particularly long time when people are talking about effectively removing entire ways of doing things, and at a time, no doubt, when there's going to be a lot of economic challenges and requests for funding from a number of sectors. You did also mention subsidies. I mean, in an ideal world, where would you think the subsidies would be best used to achieve the most impact, and how can we actually assist all these great companies? You've talked about a number of very large companies, so there's also a number of great UK companies here as well, to make sure that the UK stays at the forefront of this market and can develop it both for internal use and exporting it globally.
I think you raise up a couple of good points there, and really the two main questions are related to, are you talking about the high volume players? So there we're talking about maybe the major manufacturers like JCB, Caterpillar, Perkins and the like, or are we talking about the more bespoke off highway or small volume players? So for the high volume players, it's really about the subsidising of the product, because if you can start to get the volume of product out there, then the infrastructure will to a large extent follow. Now clearly at the moment we have a problem with infrastructure, but the infrastructure will follow because the volume of product is out there. If we turn that around and say that actually what we want to do is we want to really encourage the local market for smaller fleets of vehicles, then it probably will be infrastructure led. And that's partly based around the fact that the infrastructure maybe has more opportunity to put in local filling stations in order to support certain things. So we see the projects in some of the local governments, so Aberdeen bus fleet, Mersey Travel, Birmingham and so on. So there the subsidies are going in and really helping out with the infrastructure first, and that's drawing in the product. I think the other big driver that we haven't really talked about is the air quality one. So if we start to now think about diesel being too cheap, well, yes, you're never going to win that on a straight economic argument. But if you now start to think about the local air quality and things like the NOx situation, where we see cities like London actually being fined for local air quality, then that's driving us towards electrified solutions of some form. And when we compare a straight battery versus a fuel cell, then what we tend to find is that even as low down as a sport utility vehicle, we start to see that hydrogen actually starts to become economically competitive with a battery electric vehicle. And so that's why we're starting to see a very significant amount of fuel cell work going on down even in the larger passenger cars, but especially for the heavy duty and transport sectors.
That's really interesting to hear how we're starting to join up what feels like a lot of smaller and locally driven projects and starting to build the network out and expand to provide sort of bigger opportunities to take things forward. Sorry.
Can I just add one thing? I think you're aware we worked on the project in Switzerland for Hyundai. And their model is an interesting one because they funded a lot of it themselves. So obviously as an OEM, they're the first OEM to really commit money. But the investment in that project is, in reality, it's coming from supermarket chains. So whilst we're looking at hydrogen hubs in Teesside, we're looking at clusters, obviously in Aberdeen, fantastic. But one method for government and one method is to actually give some incentives to Sainsbury's or Tesco to say, okay, we will give you tax breaks. We will give you a way of getting these people have got big pockets, get those guys investing. Otherwise, without a really big investor in a project, you're then relying on local councils, relying on big players. But obviously, the Switzerland model is there to basically start it off and then get to a point where the Swiss Co-op and Auchan, Carrefour, all of these people will then run their own hydrogen fleets. So that's one thing that we can do. Press and push John Lewis, etc., to take up this technology.
And is that what has happened in Switzerland? Is that why they have is there a carrot provided or a stick used against the supermarkets?
It's a carrot, isn't it? The investment has come from Hyundai and their collaborators on both the hydrogen production and the distribution. So for the pumping stations, that collaboration, they're all running that together, but they're leasing it out to the supermarket companies. But we could do a similar thing here if we could find the investors to come in and just open that up. And it could be a Sainsbury's, Tesco, etc., because they are big organisations. And if they're pushed by government and given that carrot or that stick, it would be a big potential.
Bryony, there is a huge fuel tax incentive and structure in Switzerland that makes the business model work. So, as much as the points that Jim make are correct, the reality is it would need a radical change in the UK's approach to how they're taxing and supporting the transition.
Yeah, there's quite a significant ratchet in the next 3 years in terms of road taxes for diesel trucks in Switzerland. But in Switzerland, the end customer for is Anheuser-Busch. So a company that wants to be seen to be operating an electrified fleet. And yes, of course, it would be helpful if there were subsidies for those operators, but to the extent we can encourage companies who want, from an image point of view, to be adopting low carbon transport, that would be helpful too.
And we've used the word subsidy quite a few times, and we know that money is clearly one of the barriers at the moment to getting this technology out there. When we talk about subsidy, are we talking about one-off early investments? Because clearly we need to ensure that however we help the market develop, it's in a way that's sustainable and not permanently reliable on subsidies. So where would we get the most impact if we were to be asking the policymakers, and I think we have a few who may be listening today, where would they get the most bang for their buck?
The model's quite clear, isn't it? Already in that subsidies. If you think about solar kind of worked all right, but really, it was abused and there was a lot of problems. Let's sort of really focus, I think, on what we know works. And I'm with Amanda. Absolutely, it's all about tax breaks. It's do you want to you tax dirty and you promote clean? And that sounds like a COVID-19 thing, doesn't it? But it's not. It's really a hydrogen thing.
Yes. Glad someone managed to bring us back down to earth with a bump, back to COVID.
Bryony, I don't think, if you look at the quantum we're talking about here and the amount of money that's needed, the issue is because of early stage adoption. Mm-hmm. And there's plenty of cases and examples where if you can account at scale for the energy system benefits, the links into other systems, the industry has presented many cases that show if we can do it at scale, there's sufficient to say we don't need the subsidy anymore. I think the issue is an immediate priority that says if we're going to deliver a hydrogen infrastructure by 2030, 2040, where there is none existing at the moment, and that includes the lovely slide from Adam where he shows, you can plug in your electric vehicle now and it will be cheap, but if you want to do 50 electric buses, it will be expensive. Well, that's where the government needs to be focusing the money. It needs to be focusing on accelerating that curve in order for us to be able to be at scale where they then don't have to subsidise, and the likes of the big hydrocarbon companies and investors will put their own money in.
Yeah, it seems that there is very much a commonality as to what's being said here, that the longer term, bigger picture and holistic business case for these things, and in fact the wider case, environmental and social, needs to be looked at too. I think it's a point that Stuart made in connection with the hydrogen trains, that actually if you look at the comparator cost between electrifying the railway, then it might make sense. You're saying the same with the trucks, that it's scalable. Very, very graphic representation showing that once you get to 50 buses, then actually it all becomes workable. Does show that I think we're all saying the same thing. It feels like the theme is working together and collaborating to get the scale out there, making sure perhaps that it's not siloed infrastructure, that we can actually get the maximum back from the infrastructure that's invested in. It's really, really great to hear, and it's just how we get policymakers to give the certainty needed to the private sector for investment in that infrastructure, and if necessary the subsidy or tax breaks to help support it as well, to move things forward. Before we move on to the question session, I'd just give each of you an opportunity if you've got a final comment that you wanted to make. So I'll just go around quickly. Adam, in terms of your ambitions for the next 5 years, what would you like to see happen?
I don't have any sort of specific comments in terms of the next 5 years or so. Obviously, I'd like to see money directed towards the areas that need it in the sector from government. Yes, there needs to be a discussion around a proper carbon tax in the industry. And then I'm hoping that the OEMs put product into the market, because without trains, planes and a good choice of heavy-duty vehicles, there won't really be a scale-up. So the OEMs have to have confidence that there will be the infrastructure support to make this happen.
Excellent. Amanda?
I would suggest that we have an approach that is available now, and that we shouldn't hold out for the perfect in expense of the good. So my message, and it has happened before, government, when they funded the HTAC program, specifically excluded hydrogen combustion in any ability to apply, which to me and many of the infrastructure suppliers competing was absolutely madness. We deliver something that's part of the process that helps make the economic case. Why would you exclude what is available as long as it's part of a roadmap? And we're in the roadmap, so why would you exclude it?
Indeed. Stuart?
So I think it's quite simple. I think the rail industry has really accelerated recent efforts in this area. They realise they've got to get the job done quickly, and in the next 5 years, I'm pretty sure we'll see a small fleet in passenger service somewhere in the country, probably in Teesside or somewhere like that. But and many more other planned introductions. The technology is ready now, so it's more about deployment than developing the technology. So I think watch this space, because the rail industry can move fast when it wants to, and I'm pretty sure it will in this case.
Excellent. Jim, Keith, a word from Luxembourg. What would be the next? And I choose 5 years because politicians think in much shorter timescales than we're talking about here.
Absolutely. Go on, Jim, you go, and I'll...
Well, certainly I'm with Amanda. we have the technology anyway. We need to bring in the investors. The technology to do it is there, and I wouldn't personally rely on OEMs. I think harking back to Tesla, all the OEMs thought that they watched Tesla do all the groundwork and develop electric vehicles, and then they'd tag along, being the second mouse to the trap. They wouldn't get, they'd get the cheese, but they wouldn't get killed. They got that wrong. Tesla's now stolen their lunch and is pushing them all into a very difficult position. So get the investors in, get them building the little projects, the Sainsbury's, etc., and that's something we as an organisation can influence.
And add into that, I think we're manufacturers. It's manufacturing. It's a manufacturing success story in the UK. Lots of us, and I don't mean lots. I just mean lots of people on, and we need help to expand. And that means, about planning. It means about making space available for us. We expand our plants, and somebody put to me a few months ago, this is like the dot-com bubble, and the dot-com bubble, they were also talking about market sizes of trillions of pounds at the time. It's all, let's not forget that relatively recent history, and let's think about what did California do to create Silicon Valley. And the government don't need to be necessarily that smart. Just look around, let's see where all the success has been in the past, and let's try and recreate that. And yes, it's a lot to do with, back to what I was saying before, infrastructure, helping manufacturing, and basically concentrating on educating and promoting this wonderful opportunity that we all have.
Thank you. And I think that, John, you're the final panelist to have a word on this. So.
Yeah, so from my perspective, one of the things that we're seeing is that we're starting to see some real volume players now looking at fuel cells and hydrogen. And I think that's, for me, is one of the big things that's going to drive us forward, because once we've got that, we'll start to see the costs of the fuel cell system start to tumble. And when you get into the real large-scale applications, then that has knock-on impacts to all of the other sectors and starts to really open up the opportunities. We are seeing political drivers along the city bans, the internal combustion bans. We're seeing the Asian markets really starting to get behind this, along with Germany and France and a few other people. So we need to ask ourselves the question, do we want to wait and just respond, or do we need to try to get ahead of the curve, or at least stay up with the curve? That's really the fundamental question from my point of view.
Sounds like a challenge for everyone rather than a question, John. I suspect most people know where they would like to be relative to the curve. But thank you very much to the panellists. I have unfortunately overrun a little bit, but I picked up some of the questions as we've gone along, but I'll hand over to Chris in case there are any that I have missed, and to close off the session.
Thank you very much, Bernie, and thank you very much to all of the panelists for all of your comments and feedback in the presentations. I'm sure many of our participants have been noting that there have been a number of questions in the Q&A, and I think one of the themes is how diverse those questions are, which I guess reflects the very diverse nature of our panel and the very diverse nature of the discussion that we've been having this morning. That being the case, and the time being the case, there's two areas that I did want to pick up on. One, because I think it's a theme that has come up a lot, and I wanted to maybe ask a direct question around it, which is on infrastructure. So consistently throughout the panel, I think members have been very clear in saying that there are technologies and opportunities that are commercially available, and the challenge is scaling up, and have spoken at length about initiatives in other markets and about ambitions being set in other markets, and around why the fact that the UK doesn't have a hydrogen strategy and that there isn't a subsidy support mechanism and various other things are holding back the market, and how can we get investors in. My question to the panelists is it really a supply side of hydrogen challenge? Is that really the issue, or actually is it to do with a demand driver? And I ask this because when I sit and talk to a lot of investors, what they say is we need long-term bankable projects to invest in infrastructure. And transport is famously difficult for long-term offtake structures. You don't typically get offtake structures that last for more than a period of 10 years. It is hard unless it's a public sector contract. Certainly, if we talk about the rail sector, most franchises were historically 7 years. so short by the terms of a lot of infrastructure investors. So how do we actually create that comfort level that there actually is the demand, and how do we actually then create a structure that is then appropriate for investors to come in? And is that something more to do with pushing businesses and pushing franchise owners and pushing operators of shipping lines, ferries, etc., to be more aggressive and expecting consumers to push them to be more aggressive, as well as simply talking about a price support and a subsidy? And we noted Switzerland, and I thought that was a very good example because that has been very demand-driven as much as supply side. So maybe I'll also start with the team from Luxfer and ask, maybe you can comment a little bit on the question first, and then we can expand to some of the other panel.
Well, I've got one live example for you, and that is if you're into hydrogen on LinkedIn, there's a company called Josh Shulman. They've made the first hydrogen tractor, and you know what kind of technology they're using for that, Amanda, and that they've got bags and bags of interest. They've got lots and lots of orders. The thing that's holding them back is the relatively slow availability of hydrogen at their customer really, and that's one example. Things are going incredibly well. They're going to make hundreds of tractors, but it could go faster if the infrastructure was available. That's them telling me, not making it up.
So maybe then to just get sort of that financing perspective, and maybe I can ask Adam, what sort of, you're speaking to obviously a number of people in different capital markets, financial markets. Do you feel that the characterization that it's just investment lacking in infrastructure and government subsidies is the only thing holding it back, or do you think that there also needs to be more of a demand side push as well?
I'm optimistic. I mean, we've had a discussion today about some of the bottlenecks, and that's understandable because as industry participants, you'll see that the groundwork is put in place in the UK to be as fertile as it can be. But I'm pretty optimistic. We do make the point again that it's a 5 or 10 year process to see full availability of products in truck. In bus, perhaps it's a little bit earlier. In plane and train, the economics will improve over time as the capital costs of the equipment come down. But I would certainly say in the case of bus and truck, we're pretty optimistic. And I would say it's a question of time to the extent that you see truck product going into the marketplace.
And maybe then moving off the infrastructure question again, conscious of time, another thing that I've noticed is that if we are talking about the UK falling behind in other markets taking a lead, we come to this question of talent and resources and actually having skilled individuals with the capabilities to actually build and manufacture, assemble these technologies and deploy them in the field. And maybe starting with Amanda, sort of, do you feel that the UK is actually doing enough to make sure that there is a pool of talent coming through and doing enough to retain talent that we have so that, if the infrastructure challenge is resolved, there actually are then going to be that resource base for companies to draw and actually expand to meet that demand, or is that still a major challenge?
In our experience, we're able to find people that we want to recruit. There was a lull in engineering recruits about 10 or 15 years ago through universities, but I do believe that our current requirements can be met, particularly as it's, in our case, a transferable skill from existing industry. Engineering is certainly something we have as a high-level skill. So I feel like what we do need to do is make sure that we can continue to have the best quality recruits. My most recent recruit isn't a UK citizen, and will become a UK citizen in the next year or two. But we need to make sure immigration and those kind of policies are still keeping the door open for us to be able to recruit the best talent.
And Stuart, maybe to you, I mean, are you finding that of all the talented young, engineers that are coming out of University of Birmingham, that people are excited about staying in the UK, or is the fact that there isn't the infrastructure and there isn't the strategy actually encouraging a lot of the people who are working on these exciting projects, like the HydroFlex project, to then look at alternative markets and to go and work in those locations first?
Yeah, well, we have something like 1,000 students in our School of Engineering across civil, mechanical and electrical, and they generally don't have a problem getting a job. I think the key thing to remember is our sector is competing with other sectors like oil and gas and electricity and other transport modes and so on. So yeah, it's a competition to get the best students into their company. I would say reflection on the HydroFlex project is we have had support from government through the FOAC scheme, first of a kind in the rail scheme. But if you compare it to kind of the coordinated efforts that you see in other parts of the world, I'm thinking particularly in Germany, you've got a much further advanced. They invested more heavily in this and more strategically, I think, than we've done. So we're doing well. If we got a bit more focus, I think it would help a lot. But yeah, the engineers that we produce do get attractive jobs in the UK, but equally, we produce a global product, if you like, and it's good for us as a university to have people going off into all sorts of different places and all sorts of different parts of the world. So while I like to keep them here, equally it's good that they can get jobs overseas too.
Very good. And just a final question for John from AVL. Question maybe just on the commercial vehicle side. Where do you see the sort of initial market for sort of the fuel cell hydrogen applications in terms of the types of commercial vehicles? Maybe you talk a little bit to where you see in the immediate 5 years, what is the area that's of greatest interest to you? And I guess maybe talk about, is that actually even going to be in the UK, or is realistically the next 5 years for commercial hydrogen vehicles still too early?
So, good question. I think in terms of the commercial vehicles in the UK, it's really going to come down to the infrastructure, and I don't see massive penetration in the short term, apart from potentially some of the localised fleets where the comment was made about Sainsbury's. Now they're the sort of people that could potentially have the hydrogen infrastructure at their depots, and so we may see some localised impact there, but I don't see a major fleet across the UK generally.
Well, look, we're at time, so I want to. Unfortunately, there's always more questions than we really have time to go through. But I think we do have some emails left at the end of this. So if anyone who was attending this discussion would like to follow up with our excellent panelists, then please do get in touch afterwards and reach out to them. I guess in some sort of closing comments to wrap up what has been a very wide-ranging discussion. It seems to me that, one of the main narratives at the start of this year when I was speaking to a number of people, whether it was policymakers, investors or customers, was, is hydrogen really a viable option? Does it work? Are there any examples of this? There was a lot of just general lack of awareness and understanding. And I would say, the more that we go through discussions like this, the more apparent it becomes that the wide range of hydrogen and fuel cell applications have already been demonstrated. There are multiple pilots, a number of good case studies and bodies of evidence to draw on, and perhaps, we need to, I think as the education piece is rolling on, we are getting into these more interesting questions which are around how do we ensure the infrastructure is there, how do we ensure it's financeable, and how do we ensure government is putting a sensible strategy around that. These are obviously difficult and challenging questions, and I think certainly the context of COVID has not helped to make this the case. For example, the UK's comprehensive spending review has certainly been delayed as a result of COVID, and many other countries will also be reviewing their budgets and plans in the light of COVID and understanding what that means for next steps. But equally, this also creates an unprecedented opportunity. There is no doubting that the need to build back greener and the short timeframes involved mean that for countries like the UK to seize the opportunity that a lot of our businesses are working hard to deliver, there is the need to act now and ensure that those skills and capabilities are developed in the UK and retained here so that we can continue to benefit from that and the innovations that come from that, rather than simply doing what has often been something the UK has been very famously bad at, which is developing great ideas, having them commercialized somewhere else, and then buying them back from somewhere else. And obviously, it's fantastic that those British ideas are very popular and that they are then being picked up. But it would be great to also see those opportunities being developed and opportunities being put forward and scaled up in the UK as well. And I think encouragingly, we do have a number of members, and the number who spoke here today illustrating that option is really on the table. And so now the challenge is to get that infrastructure in place and the production done in the right way that is safe, that is transparent, and that is commercially viable. So again, thank you very much to all of our panelists, and a thank you very much to all of our participants. Just as a reminder, when you leave the discussion, there will be a quick survey. If you would be so kind as to answer, it just helps inform our next discussion. Equally, I just wanted to also draw attention to the fact we will be doing looking to do two other webinars similar to this. One will likely be on hydrogen production, different forms of hydrogen production and different approaches to hydrogen production, and another will be talking about hydrogen infrastructure, companies working in that sector and how they're looking to put those together. We are still putting together a timeline on that. We suspect probably likely to be in early 2021, so January, February. But please do stay posted, follow us on social media, or keep in touch with Burgess Salmon, and we will keep you updated as that develops. But that's it from me, so a big thank you very much again to our host Burgess Salmon, to all of our speakers here today, and then please enjoy the rest of the week. Thank you, everyone.